Okay, well, let's get started. Good afternoon, everyone. Thank you for joining us. Hello. All right, so good afternoon, everyone. It is my pleasure to be the MC for our virtual career panel. I am Tammy McBride, Career Connected Learning Specialist for the North Central ESD. On behalf of the Central ESD and Apple STEM Network, I would like to extend a very warm welcome to all of you. We appreciate you taking the time to join us today. We hope you learn a lot in this half hour together, and we have a great panel lined up for you. We want to thank and acknowledge Wenatchee Valley College and also the Washington State Department of Transportation for joining us today and taking time out of their personal lives and out of their schedules for this panel discussion. Today, we have one career professional with Wenatchee Valley College engineering program and one career professional with Washington State Department of Transportation who will give short individual presentations about design and engineering degrees and jobs that utilize design software. The presentation will be followed by a short Q&A. As an attendee, you will need to type your questions to the panelists. If you are on Zoom with us, please type your questions in the Q&A box. If you are Facebook Live, you will need to ask your questions through the comment section there. To begin our program, it is my pleasure to introduce to you our first panelist, Arius Elivkus, Digital Design and Drafting Faculty for Engineering Technology. Arius?
Hey, thank you, Tammy. Welcome, everyone. Let's see here. We want to, and there's Tammy's information as we move forward here. So you can take a look and jot that down and reach out. But you're also welcome to reach out to me. My name is Arius Elivkus. And yeah, this is Careers in Design and Engineering. So there's me, there's my name, so you can look me up at the Wenatchee Valley College website. So I am in charge of teaching computer graphics, essentially. And I have kind of two roles at the college. I teach drafting and engineering software to students that want to go into engineering, but also a lot of our workforce ed students. So the students that are interested in machining or welding or doing electrical stuff. They'll take classes with me to just kind of learn the introduction basics to how to use graphic software to get their job done. I also teach software for 3D graphics that's more aimed a little bit towards animation or video games, as well as graphic design software, things like Photoshop and Illustrator, which are used for more commercial art, posters, publications, that sort of thing. So I'd be happy to answer questions about that, but I think we kind of want to focus on our drafting, our sort of technical graphic software here today. After that, Bree will talk to you. She was a student at WVC a while back where she took graphic software as well, and it landed her a job. So she's directly relevant to sort of absorbing these sorts of skills and then putting them to use. So with that, we have a couple of different courses and degrees at Wenatchee Valley College to kind of get you started. I mentioned the three programs I'm sort of associated with. We have graphic design, which is a 2-year degree, and again, that's the commercial side of things. So if you're interested in, like I said, posters or maybe getting into magazines or designing ads for your small business or coming up with logos or branding, that sort of thing, graphic design is where you'll want to look at. If we have some extra time, I have a few materials on that front that we can talk about at that stage. On the other side of the kind of graphics spectrum is our small drafting certificate, where you learn 2-dimensional AutoCAD, which is like blueprint software, as well as some 3D software that you would use to build machine parts to help you design an invention that you're thinking about, or preparing a file to send to a 3D printer. So we'll take a look at some of those. And then in between, we have this weird little digital design certificate, which is kind of meant as a starting point for students that maybe don't want to go hard into engineering, but are interested maybe in someday getting into architecture or animation or video games or product design, right? Every spatula that you buy at Target, someone designed somewhere. And so our digital design certificate kind of is in between those areas. In addition to that, we have some engineering degrees, which you'll work with me for a couple of classes, but then you'll be taking all sorts of other higher end engineering oriented and some math courses that can kind of feed into a bunch of different jobs and industries here in the Valley. So we can talk more about those a little bit later. So before I wait too much longer, let's look at some cool stuff that my students have put together over the years. So this, I'm going to show you a few examples of final projects, things that students have done in my class that they've produced in our kind of 10 or 11 weeks, where they sort of end up at the end of it. So right here, what you're looking at, maybe this isn't the most thrilling place to start, but this student, you can see here, took an electric pencil sharpener, and then he measured all of the little dimensions and everything, and then used AutoCAD to draw the different views of that sharpener, specifically how that little shaving drawer pulls in and out of the sharpener that collects all of your shavings. So, you know, these are the little details that a lot of students like to hone in on. They like to look at the objects in their house, take them apart, measure them, and then draw them in a communicative way, you know, to be able to say, hey, this is how big this thing is, or this is how this works, or here's where the drawer slides in to the other drawer, or here's a little zoomed in detail of the strange little, you know, plastic divot that's underneath it. So students learn what these different line types mean, and they learn how to generate these professional drawings that are kind of universal. Doesn't matter what country you're in, or what language you speak, most anyone can look at a drawing like this and start to get a picture of what this pencil sharpener in this case will look like. Other students are more interested in larger scale projects. Maybe they're interested in maybe getting into construction management or architecture, right? The whole business of making buildings. And so you can use AutoCAD to do this. So this was a student who had a fair amount of experience coming into my course. He already kind of had a good grasp of how floor layouts work, and you can sort of see he nicely built all these walls. But, you know, even things like paying attention to where the numbers go so that you know how big or long something is. Look at how nicely he organized across the top there, all of those numbers. So it's easy to read. It'd be easy for a team to look at this drawing and say, okay, here's the space we're working in. Here's where we have to start, that sort of thing. All right, so that's something that you would do in our Engineering 105 class, our Intro to CAD. Then most students who take that then proceed into our Engineering 106 course, which is parametric modeling, solid modeling. It's fancy words for saying, you know, 3D shapes and parts. So this is a mechanism a student built. He designed it from scratch. He drew the blueprints in my Engineering 105 CAD class, and then when he learned these 3D skills, he built this mechanism, and it is supposed to be like a little plastic thing that you'd stick in your sleeve to like shoot playing cards in your hand if you're trying to do a magic trick. So it's a design that he was working on. He hasn't built it yet. We don't know if it's going to work or not. But he came up with all these little sliding pieces and little gears with the hopes that he could design something like that. So that's kind of a fun application. But this software is very concerned that you are designing stuff that can actually be made, either by a 3D printer or by, you know, someone in a factory down the line. I had another student who wanted to, this was a year ago, and he was sort of into steampunk costume stuff. So he designed this sort of mouth respirator, but, you know, in our current sort of pandemic situation, I thought it was a very striking image to kind of pull up, right? So he designed these different chambers and these tubes, and it's just meant to be decorative. But whether it's decorative or you are trying to invent something like a new type of mask or respirator, this is part of the design process, all right? Being able to come up with some ideas and then show it in the software gives everyone an idea of what we're looking at, right? So he's got his measurements, and you can kind of see the little dotted lines about the empty chambers inside the sockets. So, and then you get a nice sort of 3D view of this idea that he had. It all started on a sketchbook, and by the end of the course, he had, you know, the 3D information. This was another example of sort of a toy box. The student had an idea to have sort of like a little village that when you crank the handle, different things would kind of show up and rotate and move. And so she didn't quite, you can see some hints of some gears in here. We didn't get to the point where we could actually really make it work and simulate how it would appear, but she did a nice job getting all of the sort of general pieces in place. So we get a sense of this little lighthouse and a little water wheel here, and you get the sense of this being a little bit of a music box or a toy box, right? So I'm showing you some kind of fun examples and applications, and I try to open it up and let the students make whatever interests them. But we also have lots of other things that are, you know, a little bit more straightforward, little clocks or little turntables or little gear sets. So the software lets you make whatever it is that you're thinking about, and that's what I try to encourage. This house, some people again are thinking more about architecture or visualization. And so I have a different class, Art 132, which is an introduction to 3D digital design. And we use 3ds Max in there. And 3ds Max is used by professionals like architects to build something. In this case, this student took all of my classes. So he made a floor plan in Engineering 105, and then he learned the basics of 3D modeling in Engineering 106. And then in here in Art 132, he was able to build this house based on all those plans. And then the software does nice things like put in sort of textures and the shingles on the roof and the brick on the chimney, and it can simulate the sun kind of setting and casting shadows. So we kind of try to absorb all of this. So that's a very practical application of that 3D software. But I get a lot of students that are also interested in animation or video games or building weird characters or worlds. This was a student who, I don't know how well you can see this sort of like dark, creepy, he was reading some sort of manga that had these weird blood boil trees. And so he built one of these trees and then used the software to make the sort of red glass effect and shone creepy lights through it. You can kind of see what this whole structure was. So, you know, the software can do all sorts of things once you learn how to use it and once you learn the tools that you want. So this is a bit more of a creative application of what we do. And then this would be an example of something that's sort of halfway. Again, very high-end student that had already taken a number of other art and design classes, but didn't know the software at all at the beginning of the quarter. And by the end of it, she sort of rebuilt this kind of like rustic witch's cabin with like spices on the shelf and glass jars and little stove fixtures. And then you can see the logs in the roof and this rickety old ladder. So she built this entire virtual space that's a little bit half imagination, but also a little bit based on real cabin design and real architecture. So some pretty cool stuff. All of it using different sets of software that we work together to kind of pull together. And, you know, my ultimate goal is that you as students can start to make the things that you're thinking about or that you're trying to fix or design or build in the first place. So, you know, that software is the first step. And then I usually assume that you're going to take that software and apply it to something that you want to do, right? So whether that's a future in architecture, if that's, again, 3D modeling spaces for projects or little prototypes. I've had students that, had one student who built RC car parts in his garage. That was part of his kind of side hustle. And he was able to use the software to make that process go better. And then there are students who maybe are more interested in video games or animation. And there's not a lot necessarily in that field here in Wenatchee Valley, but right over the mountains, that's where it happens. DigiPen and the Academy of Interactive Entertainment, those places like direct students directly into Nintendo and video game companies. So we can get you started and get some exposure to those software packages here at Wenatchee Valley College. So I'd love to take more questions, but let's make sure that Bree gets a chance to talk to you about how she went to Wenatchee Valley College a while back and got introduced to some computer software here, and then it kind of directed her into where she's at now. So Bree, I'll hand over the mic to you.
All right. Like Arius said, I took drafting certificate program about 13 years ago, almost 14 years ago from Wenatchee Valley College. I was in my late 20s and had kind of taken a break from college, and my mom actually worked at the DOT for about 30 years. She actually has just recently retired, but I knew what drafting was because of that. So back then, it's not too far back, but back then there wasn't a lot of drafting design kind of things around the valley. There was some programs that you could go other cities and stuff, but this was like one of the first years that Wenatchee Valley College had a drafting certificate program. I knew I had worked at the Department of Transportation as like an intern one summer and got really interested in their drafting. And so when this came out at the college, it was like a perfect fit. The program that I took was a year, about 3/4, so it was a year drafting certificate, and I actually took night classes while I was working during the day at that time. And after I was finished in June, I think it was in August, I applied for a temporary position at the Department of Transportation. I wasn't exactly sure where it would lead, if it was going to be end up being permanent or full-time or whatever. And of course, now 13 years later, I'm still there. And with honestly a minimal experience, because I started as a temporary, so they actually helped me kind of grow my skills and that kind of stuff. It was a little bit of a learning curve because we use MicroStation instead of AutoCAD, which the programs, you know, are kind of similar. They do a lot of the same stuff, but it's a different software, so you have to learn it all over again. But so I started out as a technician, entry level, and a few years later got a promotion to a Tech 3, and right now I am doing actually a temporary E2, which is an Engineer 2 in training position. So with minimal schooling, but a lot of experience over 13 years, working at the DOT, they love to grow their employees, and it's worked out really well for me, somebody that doesn't have a 4-year degree, but still has, you know, some schooling, and it worked out well for me. So the slides that I have for the presentation, I just brought some just general examples of what would be in a plan set. We always have the first page is a vicinity map. This is a project that we just put together a few months back, actually. We are kind of in a budget crisis, of course, all over the state. So we've put together a lot of these, they call them strategic pavement preservation jobs. So they are going out and they are tearing up some pavement that might have potholes, or maybe a little bit bigger than a pothole, or rutting or something. The pavement is older, but we don't have the money to totally repave, so they come out and they tear up a little bit and pave back to make it a smoother ride. So every project has a vicinity map, and for DOT, we are North Central region. There's quite a few different regions. I can't remember exactly how many in the state of Washington, but we are always going to be in the middle of the state. We have the same boundaries, all that kind of stuff. So on this one, you can see a little bit of work on I-90, SR2, let's see, Highway 26. I'm sure all of you guys have probably driven on these roads at some point. So the next slide, every plan set will have something called a summary of quantities. Now this is where DOT has kind of helped me grow my skills a little bit. So I came in as a draftsman, but now we're putting together estimates for projects, and I'm learning not just about drawing like the things for the plans, but I'm learning how to estimate quantities and what goes into each project, and different items that are needed and items that are not needed. So our next slide is some roadway sections. These, another thing I think that Arius had kind of talked about is he does a little bit of 3D stuff. In the civil, there's civil and mechanical, and let's see what else, 3D kind of drawing kind of stuff. Ours is more civil, and so almost all the stuff that we're drawing really is 2D. It's going to be plan views, side views, cross sections, that kind of stuff. This is going to be like a cross section of a roadway, so you can see that They're going to be paving, they're going to be overlaying those wheel ruts, that kind of stuff. Let's see, what's the next slide? Another roadway section, I believe. So these are, this project was a couple years ago. They actually added a left turn lane on a highway that had a lot of trucks, big semi trucks turning in and out, and it was kind of prohibiting the traffic from getting through more continuously. So this slide is actually widening the roadway, and they are putting in, there's going to be like some base course, and the different lines up here on the right, roadway section B, they're going to be putting in different lifts of a certain depth of pavement all the way up to the top, where there's actually like a wearing course to make it smooth and stuff. So what's the next one? This is going to be a site plan. It's going to have a little bit more information. It's going to show all of the existing roadway features. It's going to show some cut and fill lines if there's going to be anything on the side of the road that they're going to have to like cut into the hillside or the ditch or anything like that. Some of these plans will also show some electrical stuff like buried fiber or utilities, that kind of stuff. We have different departments at the Department of Transportation where our traffic office does, you know, more of like electrical design and stuff for intersections. And then we have a survey office who's going to go out and get you this information that you're going to be able to reference into your drawings. I think the next slide might be the electrical. Oh, this is the pavement marking plan. So this is also going to be like in our traffic office, there's different things different offices that you can work in if you have like kind of a specialty that you're interested in or whatever. But this is going to show there's all kinds of different standards, obviously drafting standards, but then when we're designing the roads, all kinds of different standards of what we have to have out there. So this is going to show all of those pavement markings and where they go. The next slide, I believe, is the electrical illumination. I think Arius talked a little bit about electrical design. This is probably not exactly what he had done, but
right. Students that are taking electrical for us, usually they'll use CAD to do more sort of like abstract flow charts. So, you know, where's the capacitor,
okay.
where's a resistor?
Okay.
But this is the civil application where you have to think about where that conduit's going to actually run.
Yep. And it's going to have to coordinate with all the other offices and where it's going and where it's coming from and all that kind of stuff. So these are just examples of things that are in our plans. The next one I think is the traffic control now. So a lot of times traffic control is like almost the majority of our plans. Obviously very important to the DOT. We want to make sure that people are getting in and out of our construction zones safely. There's a couple different ones if you want to just kind of go through the traffic control slides, all kinds of different, all the taper rates and that kind of stuff. There's charts for all of that. You can't just like willy-nilly throw something in there. If, you know, if somebody's going 60 miles an hour, the taper is obviously going to be longer than going 25 miles an hour. And lots of signs. Lots and lots of signs. We have people blowing through the construction sites all the time. And this has a lot of effort going into it to keep the employees safe. But so also in my position at the DOT, I kind of am a little bit of a go-to. I like to do all kinds of drafting stuff. And so when people need things done, for a meeting, say, this is a aerial display of Gun Road, and it's kind of back down by the cinema and right where the State Patrol and the DOT actually is right now. They are looking at restriping the road and adding more sidewalk for pedestrians. So we had to put together a aerial view of, this has, let's see, sewer line and a little bit of sidewalk there. It's kind of hard to see the existing stuff, but it shows the existing pavement markings and stuff. So not just drawing traffic control stuff or roadway sections, but sometimes we get to do more fun aerial type things. The next one is also another thing I've worked on. This is a right-of-way plan for the trail, actually, the loop trail. If you can see where the green and the red lines, this is called a red and green markup. And the green lines are actually taking out a certain line style or whatever, and then the red lines are putting it back in. So on this one, the PUD has an easement for their power poles, and they're going back and forth with the DOT and trying to decide, get a good fit. But the red lines are the easement, so they're going to be like, say, 12.5 feet on each side of the lines, and they have to have that on a right-of-way plan, so it's basically a legal document. But these are other things that we get to do with the AutoCAD or MicroStation for us software. So that's a little bit about what we do at DOT, or at least what I do. I don't know if I want to throw it back to you, Arius.
There we go. Sure. Yeah. So yeah, so that's really cool to see that stuff in action, right? In my starting classes, we have so many different students that are hoping to do different things. But some of them they know about civil engineering. They know that someone's got to think about bridges and dams and things like that. And so AutoCAD is the industry standard, but yeah, there's lots of comparable pieces of software that are going to do similar things. And Bree, when you said that you had to, learn a new set of software, even though you trained on a different set, like that's how it goes. And part of my goals to teach all these different sets of software is so that people kind of say, okay, well, I'm going to have to keep learning all this different software, and certain things are similar, and I know this software can do this, so there's got to be a way to do it in this software. And I hope to kind of just open up flexibility. I kind of compare it to languages. The more languages you learn, the easier it is to learn one more language. So that's kind of my philosophy on it. But yeah, depending on where you end up and what specifically you want to do, if you want to do airplane parts, that's going to be CATIA. It's going to be its own piece of software. So you got to be ready to be flexible. But yeah, it's fun to learn, and then you get to draw the stuff that you're thinking about. So yeah, so I guess we'll just pop this back to here. So I don't know if any questions came in.
Yeah. So if you want to pop to the last slide there, Arius, just so that they can have your guys' contact information. We did have a question come through. It said, would you recommend a certain level of math skills for high schoolers to have if they were to pursue a career?
Well, I can speak to what would be required to get a certificate or a degree. For most of our certificates, the requirement is that we have a Math 100T, and that's a sort of 100-level college math that's specifically geared towards technical students. And so it's much more practical, and they find ways that you would use math in business or in an orchard or on a construction site, and they try to make it very, very practical. If you're interested in pursuing one of those bigger engineering degrees, and Bree, I don't know what the math requirements were for your drafting program when it happened. Once you get into a 2-year degree, you're going to have higher level math, and to become an engineer, and I'd love to hear what Bree has to be doing now to prove her sort of engineer level math. That can kind of start to go up pretty quick. But as long as you're still on the machining or welding or just technical drafting side, the math doesn't get crazy. It's very geometric. So if you can sort of see a 3D form in your mind and kind of understand how long this side is versus that side, that's better. And then, when you look at all those blueprints, if I pop back up here, you can see there's distances in these dimensions, right? So you got to be comfortable with distances and estimation, and you have to be able to, if I go way back to, some of my floor plan layouts here, right? Sometimes you're not going to see a distance, right? I've got this overall distance of 42, and I've got all these smaller distances, but like if I needed to know this distance right here, I'm sorry if you can't see my cursor, I'm looking at like on the right side between the walkway, the staircase, and the master bedroom door. Doesn't say how far it is, but I have all these other dimensions all over the place that I'm going to have to maybe just do the arithmetic in my head. So if you can have a handle on kind of popping out a calculator, be able to make sketches and kind of determine what the differences are between certain numbers, that's about as like formal mathy as it gets in terms of starting to learn the software. But you know, once you're at Bree's level and you have to worry about, is this structure going to hold up this gravel or not? Then I think the math goes woo.
Oh, and when I took the drafting class, the math, of course, was really low. It was not a degree, so the math was really low. But that's kind of the DOT, like I said, and I think when you get hired on by a company, if you do have like very low experience, you want to talk to them about that. I have learned so much in the 13 years that I've been working there, and had so many great people to help me through those math calculations. And there's tons and tons of different manuals and that kind of stuff to figure those things out. But really, the people at DOT all of them have been teachers to me. So that's been wonderful for me.
Yeah, I've heard that a lot, that most places, if you can show that you're taking these classes, that your grades are okay, that your attendance is good, that you're paying attention, and you know the instructor can vouch for you, I think a lot of businesses in our valley especially are excited to home grow young people and will give you the specific training. Bree, when you showed this one with the roadway section, so even though it's drawn in 2D, we're seeing these slices, and then you know we look at it from the top view another way. Do you feel in your mind, Bree, that there's like a 3D box or something? Like, do you see this stuff as it is like in the real world, and then you can interpret it into 2D, or how do you describe that mental process?
Definitely. I mean, well, and drawing roads, of course you can see them. You just look out the window and you can see it, you can picture it. But really picturing it, the 3D in your mind is a huge to being able to draw the cross sections or the plan view, that kind of stuff. Yeah.
So I asked that because you maybe a student's not feeling really good in their math classes because it's abstract and there's equations and you kind of get what X is supposed to equal, but it's sometimes hard to plug it in. Every step of the way in these drawings, you're seeing the numbers, you change a number, the line changes, you change the line, the number changes. And so it's all linked together. And so I think that makes it easier for a lot of students to start grasping the math that you need for this kind of stuff. But again, if you're building a bridge, you need a lot more math. You need calculus and
need a lot more math.
and here, once in a while, you might get a pickle of figuring out an angle on a triangle, right? So you want good geometry, maybe a little bit of trigonometry here and there, but that you can learn that while you're learning the software. You don't need to know it before.
Yep. And the software, honestly, I'm still learning after 13 years. There's shortcuts and different things that you don't use every day, and then somebody else comes over and is showing you how to draw something new, and they use their own little shortcut that they have, and it's like opens up a whole new world. The software is just so big and can do so much stuff that, I mean, the introductory classes are great, but you're going to learn so much more even after that.
And so maybe, yeah, my last comment on that front would be the goals for my classes, and certainly for any of the certificates, is that by the end of it, you've got that packet, right? That you designed your little magician's card device, or you mapped out a new back porch or a new garden arrangement for your front yard. And you can depict that when you go in and you talk to a company and you want to intern, and you can hold that folder to them and say, here's the stuff that I drew in these classes. They're going to see it. That's an immediate, real, tangible thing. And that's where I try to get students. So.
Thank you. What skills do you think are valuable for your job?
Is that to me?
I think maybe both of you, but Bree, I would suggest that that was probably to you.
So as a draftsman, you you're going to be part of a team because you're not the engineer. You're not the one that's really designing. You're the one that's kind of putting the designer's vision on the paper. And so for me, I would think that one of the main skills will be communication, working with your team members and stuff, and being able to go back and forth and submit your drawings and take the criticism or the idea changes or that kind of stuff in my line of work.
There's regardless of which field you end up in, you gotta like sitting at a computer for a while. That's definitely part of it too. You'll have the conversations where important decisions are made, and then your job is to go back to your computer and then do the work. And so there is, you know, I get all kinds of students. Some of them have lots of actual, you know, construction experience, and, you know, sitting down at a computer to do this stuff is difficult at first, but there's a flow. And once you get how it goes, you kind of zoom in. It's similar to what happens when you play a video game. I think you just kind of start seeing the details and focusing. So that's kind of a soft skill that's important to consider. You know, if you want to be building the roads and be out there in the sun, that's one thing. And it's a different sort of mentality to then sit down and hone in on it. But I've met students that have both of those sort of proclivities. So I would pitch
So
that
actually, so you kind of just mentioned that about building the roads, and it's kind of just a little bit of a plug for DOT, but in North Central region where we're at, we're a very small region compared to some of the other ones. And we actually do, like, if I wanted to, I could, you know, choose another spot in the DOT to where I can do the drafting, and then I can actually go out and see the project being built, which is really a neat thing. And I have been on a few of them. I don't enjoy the construction as much as some of the other people, but so that, you know, is kind of like the whole package where you start to finish.
Thank you. How can I best prepare myself while in high school for college or university?
So keep doing what you're doing and take high school seriously. You know, at Wenatchee Valley College, we get a lot of students that maybe don't necessarily want to go to university. They just want to get into something new and stay in town. And so those maybe things that you need to worry about are a little different than if you do ultimately want to go into architecture or higher level engineering, that you want to design cars or bridges or houses or skyscrapers or whatever. Obviously that requires a lot more. But part of what Bree just said about communication and networking, that's a big thing, right? And this is hard for me to say as a computer software teacher, but you know, if you really like software enough, there's YouTube and there's all these online courses where you can learn the software. But until you're thinking of projects to do or working with your friends and coming up with things to draw and apply this to, you know, you can learn all the software in the world and it won't matter until you plug it into something that you want to do. So I would say at the high school level, you know, your classes are important, but you know, if taking a shop course or if you've got a great club, a robotics club or something like that, where you will have real projects and real things to compete in or to build towards, that's going to help with this a ton. And I say that because I hope maybe that's not an obvious thing. Like, obviously, we like to see that you get good grades and that you have good attendance, but the students I see at the college level that don't have something to latch it to some kind of general idea of where they want to go with this or what they want to depict, learning the software is harder. And I liken it to languages again. You know, if you learn to speak French, but you never want to go to France, then it's going to be a lot harder than learning French and then trying to talk to people in that language. And I think there's an equality there, an equivalent with software. You want to know what you're drawing, or what you're doing, or who you're working with, or what you're trying to build with your friends. That makes this stuff easier.
I think the last question is, would you suggest me going to a college versus a university starting out for design engineering?
So, you know, being biased at a community college, it's a good place. I would say the students that I know that are very eager to get to a four-year university can do that. If you're focused and you're paying attention to your AP classes in high school, and maybe you do a few low-level things during the summer at WVC, you take a math or an English course, something that you know is going to transfer right away. That can help. But then if you're not sure and you want to dabble and explore a few places, that's something really cool that we can offer that's here, that's way less expensive as far as tuition is. You can take one of these drawing courses, or you can take a higher level math course, or you can take all sorts of other courses, a normal art class or a music class, and see what sticks. And then, you know, it won't sting as bad if you, like I took a video editing course in school, and then I knew that I was not going to do video editing anymore. Like I learned those skills, I was very grateful for it, but it was very good to know at that point that that's not exactly what I wanted to do, and learn that early on. So that's a nice way to think about it here. But you know, learning the software, I have to tell you, if you go to Wazoo or UW right away and you want to get an engineering or design, they're not going to walk you through the software for the most part. They might give you an online module and say, go for it. Here's the AutoCAD lynda.com link. Go watch it. We're going to start, you know, drafting stuff immediately in our principles course. So that's another advantage we have with our technical programs at a two-year college or a small community college, is that we have a few more of those fundamental, like getting built up kind of skill classes that at a university, they might just be like, you should know this already, right? Like we got to talk about, you know, loads or metal tensile strengths, or here's their fluid dynamics calculations, plug it into the software. The software is just kind of on the side. So that's an insight. I don't know if that exactly answered the question.
I think that's good. All right, so if you are on Zoom with us, any last final questions, please put them in the Q&A. If you are on Facebook Live with us, please put them in the comment section. We'll open up just maybe one or two more questions if there are. Okay, well, with that said, I think that sums up our virtual career panel today. I want to thank you all so very much for your participation in the virtual career panel. I hope you enjoyed this program. If you need any further information or you have any questions, you can reach out to Arius or Bree. Their contact information hopefully will be posted here in just a sec. There we go. Their contact information is posted. For more information to keep up to date on these types of events or virtual career panels, you can follow us at Career Connect Chelan Douglas Facebook page, or you can also follow our Apple STEM Network Facebook page. In closing, on behalf of the North Central ESD and Apple STEM Network, we would like to thank Wenatchee Valley College and the Washington State Department of Transportation for their participation today. Thank you all so very much, and I hope you have a great rest of your day. Thank you all, and we will see you soon.
Thank you.